Good morning, everyone. This is Jill Florent. I'm with the Amazon QuickSight team, and I am a Senior Customer Success Manager here today just to give you a couple of initial instructions on today's learning series. We are here today to hear from Chris Elliott, our Senior QuickSight Product Manager, on the topic of anomaly detection and forecasting, two of our most important machine learning features. So just to make sure that you're in the right place, we are going to zero in today on these, as I said, very important machine learning features, including configuration analysis and how to explore via contribution analysis and what if scenarios. So if that sounds good to you, let's keep going. Just a couple of key details. We appreciate your taking the time to join with us today. And one of the things we want to do in addition to covering the content is to give you the benefit of an experience that includes Q&A. So the best way to actually find answers to your questions is going to be from this point forward in the QuickSight community, which was relaunched recently and has several exciting components to it. If you take a moment to simply click on the link that I put in the chat window, or if you're watching on video, take a picture of the QR code on the screen, that will take you directly to the community. And just a quick highlight that what we can do on the community is basically have questions and answers. When you initially log in, you will have to create an account the first time, which is going to leverage your Amazon.com account. And then you'll see that we have the Q&A section as well as other resources for learning and engaging with our team. You'll notice here that the questions are sort of sorted that have already come in. You'll see that there's already quite a number of questions that are being asked and answered. If you had a question that was already on your mind, like if I search for the donut chart, for example, you can see here that there's a lot of questions that when you come to QuickSight community and the Q&A section, you might already have a question answered for you. So that's going to be a great way. Each time our experts are asked questions, we literally are now asking people to post them in this Q&A area, and this is where we'll answer them. So each and every day and moment, the knowledge base here gets even better, and the questions are sometimes answered by users of QuickSight, and every so often throughout the day, our team is answering questions. And for today's session, we will have moderators that will be standing by and looking to get questions answered from our solutions architect team. So again, that's just a short intro to thank you in advance for not only your attendance, but also the questions that you'll post. And I would ask that when you are typing in a question, if you add the tag QLS-anomaly, that's the tag that we're going to use for today. That'll allow you to find any questions that come up on the topic of anomaly detection and forecasting, which is what we're going to now turn over to Chris to present to us. Actually, one final point I will say, we are recording the session today, and the recorded session will be sent to the YouTube channel, which is another good thing for you to bookmark and subscribe to, as we are posting content there all the time. So I'm going to stop showing my screen and turn things over to Chris Elliott. So give me just a moment. Okay, Chris, over to you, and I will confirm for you. I can see your screen, and
excellent,
and I can hear you just fine. So thank you, Chris, for the next few minutes focused on QuickSight anomaly detection and forecasting.
Great. Yeah, thanks for the introduction, Jill. So again, today we're going to be talking about QuickSight's ML Insights features, namely anomaly detection and forecasting. So just a rough outline of the agenda for each of these features. We'll go through what they are, how they work, and we'll do a live product demo of end-to-end configuration, deep dive on some of the features and some of the use cases for each of these. So starting with anomaly detection, so what is anomaly detection? In general, anomalies are data points that deviate unexpectedly from an observed pattern. Whatever that pattern is depends on the context of your business, but the idea is that there's some pattern, there's some way to reasonably calculate expectations and deviations from those expectations. QuickSight anomaly detection finds anomalies in time series data specifically and services them via narrative form insights. So this screenshot is just an example of what one of them might look like. If you're an existing QuickSight user, you might have seen something like this before on your dashboards. So we'll call out the most recent detected anomaly with the value that we expected to see, which in this case was just shy of 61,000, and the actual value, which in this case was 1.1 million. So clearly an anomalous data point here. And there's also the ability both for QuickSight readers and QuickSight authors to dive deeper using the Explore Anomalies feature, which takes you sort of beyond the dashboard and is something that we'll get into more in the live product demo. So how does this all work? Our anomaly detection algorithm learns from trends and seasonality, et cetera, in your source data. It uses this knowledge to generate expected values for each of the periods in your data. And in this case, a period is whatever the date granularity in the source data is. So if you have your chart set to hour, then one period is 1 hour, and so on and so forth. We'll then calculate deviations from these expected values as far as the actual data points are concerned in order to identify which ones of those actual data points are anomalies based on what we expected to see. We store all this in a data set that's sort of on the back end and surface to QuickSight authors the ability to filter down the results that they want to have appear and that they want to publish to their dashboards and turn around to their business users in those narrative form insights. And this screenshot is just an example of what those config options look like. More stuff that we will get into in the product demo in just a minute. So there's two different parts to our anomaly detection algorithm. One is our online algorithm, which generates suggested insights by analyzing only the time series present in a visualization. So what that means is you're in an analysis and you have multiple visualizations on a sheet. And if you click on one of them, then you'll get suggested insights. And if applicable, among those suggested insights, we'll have anomaly detection results from our online algorithm. But this, again, is only looking at the data that's present on that visual. And it's sort of supposed to be an inspiration for authors or a jumping off point for authors to really dive deeper on insights in their data that they may not have known were even there. And so both of these types of suggested insights are available only to authors. They can't be published to dashboards themselves, but you can use these as launch points to configure our offline anomaly algorithm, which I'll talk about in a second, which is what generates those narrative form insights that you can publish to dashboards and turn around for your readers and your business users. So the offline algorithm analyzes up to 2,000 periods or data points. Again, in this case, a period or a data point depends on the date granularity in the source visual, and up to 1 million metrics per anomaly job. And in this case, one metric is one unique time series. So if I actually back up one slide just to demonstrate that a little bit further, the screenshot on the right, you can see in the background that there's two lines on that chart. Its revenue split by this dimension is closed, which is a Boolean. And so in this case, if we were to use just this chart, that right there is two distinct time series, so that counts as two metrics. But obviously you have a lot more room to grow there because a single anomaly job can handle up to 1 million distinct time series or distinct metrics. It's based on a random cut forest algorithm. We have some links here that we'll send out to you in the chat. So one is to the QuickSight specific documentation. Another is to an open source example for those of you who might be a little bit more technically savvy, who want to dive into some of the details. This example comes from our Elasticsearch team. It is not exactly the algorithm that QuickSight uses, but it is a good enough approximation of what an anomaly detection algorithm might look like. And so if you want to drill in deeper on the details, you can look at their open source materials there. We do charge for anomaly detection as part of our Enterprise Edition offering only, and then there are additional usage charges on top of that, depending on the total metrics processed in 1 month. And so this last link is just out to our public pricing page where you can see the table that breaks down how much anomaly detection costs. And then finally, the offline algorithm can be used to trigger email alerts. So again, we'll get into this in the live demo, but sort of the workflow would be that an author sets up the offline algorithm in an analysis, publishes it to a dashboard, and then any consumer of that dashboard can use that narrative as a way to trigger email alerts. So now let me jump into QuickSight and show you some of this in real time. So just starting from a simple line chart here, I've got revenue split by region. And so there's 3 total entry points into setting up anomaly detection, 2 of which, as I was showing before, come from our online algorithm and 1 from the offline algorithm. So if I have this visual selected, and then I go over to the Insights panel on the left-hand side, if we detected an anomaly as part of our sort of offline insights generation, then you'll see the card here. And I can click the plus sign to add an anomaly type insight to my analysis. And because I started from this visual as a source, this insight comes pre-hydrated with all the relevant fields already set up in the field wells. The other entry point from the online algorithm does exactly the same thing, but it's just in a slightly different place. So on this visual, you can see that I have the Insights light bulb icon, which has a blue notification indicator. If I open that up, you'll see that I have the same anomaly insight over here that we were just looking at in the Insights panel. And if I hit set up anomaly detection, the same thing will happen. I'll get a blank anomaly insights card that I can start from that is pre-hydrated with all the fields that were in this visual. But I can add more fields if I'd like to. The third option is to go in from scratch directly through our offline algorithm. And that would just be by going up here to the Add drop-down menu, going through Add Insight, and then selecting Anomaly Detection. So in this case, I'm not starting from a visual as a springboard, so you'll notice that there's nothing in my field wells. This is truly starting from scratch. But just for the sake of an example, I'll just add the same fields that I'm using up here. So date, region, and weighted revenue. And now I'm ready to get started. So from both of these, if I hit get started, it'll bring me to the same experience. And this is our offline anomaly algorithm configuration. So just a couple of things to note in here. First, we show you compute options, which is basically going to be where you're able to set the permutations of the fields that you've included that should be analyzed as part of the anomaly detection job. So in this case, we just have a date, a metric, and a single dimension. There's 3 different options for the combinations therein to be analyzed. And if you hover over this tooltip, you'll actually see a preview of what those permutations are. So if I select hierarchical, it'll incrementally add categories, dimensional categories that I've added. And so in this case, we'll be looking at these 2 distinct permutations of the fields. If I select exact, it will process only the exact order in which I've added these fields to the field wells. And if I select all, in this case, this will look just like hierarchical because I only have 1 dimension added. However, if I were to add more dimensions, and we'll get to an example of that later, then what you would actually see is that the all setting for combinations to be analyzed will look at every dimension individually as well as incrementally, as well as every unique combination of every dimension category. So really everything under the sun gets processed when you select all. Next is display options. And so this is what I had the screenshot of before. This is where nothing that you set in here will change the input data set to the algorithm or the behavior of the algorithm. This is all about filtering the results that get shown in the resulting narrative. So you can control the maximum number of anomalies to show. By default, we only show anomalies in the most recent period. But if there were more than 3, in the most recent period, then you could up this number. If you set it to 10, for example, and there were only 3 in the most recent period, then we would only show those 3. The severity is a measure of the number of standard deviations away from the expected value that the anomalous point was. And so we sort of apply some metadata here. We call them low, medium, high, and very high. And so you can sort of If you have a noisier data set, then you might select very high or high and above, just to see only the things that were the most anomalous. If you have a more stable data set, then you might select low or medium, so that you see any anomalies that we detect that are coming through. Direction, pretty straightforward, just whether you want to be alerted when things are anomalous because they're higher than expected or lower than expected or both. Delta is a way for you to sort of set with more granularity the severity of the anomalies that you want to see. If, for example, you had severity set to low and above, but really you don't want to see any that were less than, say, a 25% difference from the expected value, or 100,000 units different from the expected value, then you could set those explicit numbers here. And then finally, there are a couple of different options by which we'll sort the results, which are just the bullet points in that narrative insight. So second to last, we've got scheduling. By default, just note what it says here at the top. The schedule here only applies once you've published anomaly detection to dashboards. So again, we do charge for anomaly detection, but if you're just sort of kicking the tires in analysis mode, trying to find some insights that you want to turn around to readers, we only charge you for the jobs that you manually run. So we don't set up any recurring schedule as long as the job is confined to an analysis. But once you publish to a dashboard, then these schedules will become live. And so just make sure you've got them set to refresh on the cadence of your choosing, so that your readers are getting the most up-to-date information. And then this will run by default as soon as you publish on that recurring basis. And last but not least, top contributors or contribution analysis. So as an author, I can pre-select up to 4 dimensions that I want QuickSight to analyze as drivers of the anomalous points. And we'll get to this in a second, but basically what that will mean is that readers who then go and use our Explore Anomalies feature will see these things on screen by default. They can also change the fields that are there, and if as an author I didn't add any top contributors, then readers can configure it from scratch. But as an author, I'm probably the closest to my business data, and so I probably have the best idea of the fields that I want to include right out of the gate. And so I might save the readers some time and add that little bit of context so that they can see the results of contribution analysis as soon as they launch. So if I were to just go ahead and click Save, what I'll get down here is a Run Now button, and that kicks off the offline algorithm. But again, this runs across up to 2,000 data points across all the different permutations of the dimensions that I added, and so it might take a while depending on all the fields in your configuration. So let me just jump over to this other tab where I've got a couple of things pre-calculated. So this insight card here is exactly what we just configured. It's just that it's already run. And so the most recent anomaly that it pulls out, March 2016, obviously this example data set is a little bit in the distant past year, but March 2016, where weighted revenue for the US was 16 million as opposed to the expected 12.2 million. So let me just hover over that point. So here's March, and the orange line is the US. The thing is, I can sort of see with my own eyes that that's a bit of an anomaly. If we were in March 2016 and I didn't have any data beyond that point and I saw these numbers rolling in, I'd think, holy cow, we're doing pretty good on revenue this month. So I don't need anomaly detection per se for this, right? And the answer is sort of yes. The real value in anomaly detection is in analyzing just a combination of tons of different things that you couldn't possibly reasonably parse manually, or that would even be impossible to parse manually because there's just too many cell values that you're trying to slice the data by that it wouldn't even be able to be plotted on a chart. I've got an example of that down here. So just looking at this chart, where we're splitting weighted revenue both by salesperson and opportunity stage, 2 different dimensions in my data, I can't make heads or tails of this just by looking at it. But if I wanted to monitor anomalies sort of at this level in the weeds of the data, having an algorithm do it for me would be very useful. And that's exactly what I've got down here. So this is showing me, and I'll jump into the configurator in a second just to show you the differences between what we just looked at and when you're configuring something that's slightly more complex. But here it's actually pulling out anomalies both in salesperson and in opportunity stage again, showing me the actual value and the expected value for both. So if I jump into the configuration menu here, you can see that I've got it set up. There's actually 2 dimensions here as opposed to just 1, whereas before we were just looking at region. And I've got it set to all. And so now you can sort of see, if I hover over this tooltip, that first we analyze just month and revenue, then month revenue salesperson, then month revenue opportunity stage, and finally month revenue and salesperson and opportunity stage. So it's looking across all the different permutations of all of those things. And in this case, I've pre-selected 2 fields that I want to look at via our contribution analysis feature, so lead name and segment. And so if I were a reader and I was on the receiving end of an insight like this, I'm not being bothered with this line chart. The author has already said this is way too noisy to make heads or tails of. I'm going to set it up so that readers can consume data sort of in this format. And then I would have it on my dashboard, something like this. And I would also be able to go through and explore anomalies. And so this loads up, and by default, as you can see, it's highlighting the 3 anomalies that were called out on that insight card. It's showing me sort of a highlighted trend around the anomalies to try and visually indicate why these points were called out as being anomalous. And then also over here, I've got the contribution percentages for the different cell values of the lead name column and the segment column, which my author had configured for me. I can also change these things if I want to see the impact of other dimensions in my data. And last but not least, I can go to show anomalies by date. Again, by default, we're just calling out the most recent anomaly, but here I can see the number of anomalies on any given day going back in time. And if I just at random, I pick April 2016, then it'll load up what those anomalies were and the contributing percentages, again, coming from lead name and from segment. So this sort of goes beyond the dashboard, but it's just a great way for readers to further explore the data, if they're curious about what's behind these results that come in their anomaly detection insight. Also from here, as I mentioned before, you can configure an email alert. So fairly straightforward. We just give you some filter options that are similar to what the authors are able to set. If, for example, the author has this set to low and above, which I do, but as a reader, I really only want to be alerted if something is super anomalous, very high, then I might change that setting there. I might change the direction, and then it'll automatically send emails to the email address associated with my user. And the last thing to say here before I cut over to forecasting is just the way that you would estimate sort of the number of combinations of things that are going to be analyzed in your anomaly detection job. Maybe you could use that to estimate cost or just get a sense of the scale, how long it might take. So in this case, opportunity stage has 6 unique cell values, salesperson has 7 unique cell values. And then you have to assume that each one of those, we would also analyze the column in aggregate. So it would be 6 plus 1 is 7, 7 plus 1 is 8. So total different permutations possible that we'll be analyzing as part of this anomaly detection job is 8 times 7, which is 56. The data points in this time series, I have my date granularity set to month. There are 72 distinct months. This doesn't affect the cost, but it might affect the amount of time that it takes the job to run. And finally, you can see that, fairly cheap, the cost per job here would be a mere 3 cents to process 56 unique time series. So even if you had that running every hour for the entire month, this winds up being just over 20 bucks. And so, if this was something that was business critical, not much to pay for our algorithm to pull out some, hidden insights that you might not have otherwise known were there. All right, I know that we're running close on time. I'll try to go faster with forecasting. So forecasting, what is it? Relatively self-explanatory, but we're making predictions of future values, again, based on observed patterns. So QuickSight forecasting can be used in narrative form, just like anomaly detection, or on line charts in this case. And here's just a screenshot example of each. So similar to anomaly detection, we learn from trends and seasonality in your data. We automatically detect these things, but in the case of forecasting, as is noted in this screenshot, we actually give authors the ability to manually tweak these things to achieve results that are sort of more consistent or more in line with the context of their business. We use this knowledge to generate expected values for each period, just like anomaly detection, except in this case, we also use those to predict further and further into the future. And we plot these points, if you're looking at a line chart, we'll plot these points along with the upper and lower confidence bounds. If you're looking at an insight, we'll plot just the, or surface just the expected value. So in this case, there's only one algorithm. It's fully online because we're only ever talking about the time series that are present on the relevant visual. And so the results are nearly instantaneous. Forecasting is also random cut forest based. And in fact, the anomaly algorithm is the backbone. And so you could think of the relationship between these two things sort of being that the expected values that come out of our anomaly detection algorithm help to generate the expected values that we wind up using in our forecasting algorithm and to predict out into the future. Forecasting requires a minimum of 6 non-null data points and can handle a maximum of 2,000. It is possible if you have holes in your data, you have some null data points. At least if you have more than 6 non-null points, then we'll use that context to fill those holes. And so it's okay if you do have some null data, but we require a minimum of 6 non-null points. And then once again, let me just hop back over into QuickSight and show you some of this in real time. So I've got several different charts here. We'll just focus on one at a time. So if I'm looking at just a single metric, sort of the most baseline case, here I've got build amount by month, and I can add a forecast again from 3 places. So here on the insights panel, I have different automatically suggested forecast insights. And if I add these to my analysis, unlike anomaly detection, which requires a little bit of additional configuration, this just gives me that forecast, in this case, forecasting out to the next month based on where the data set ends. I can add that directly to my analysis with no additional configuration if I don't think it's necessary. I also have the same thing, just like for anomaly detection, behind the insights light bulb icon on the chart. And lastly, I have it here behind the kebab menu on the chart, which is what allows me to add the forecast in visual form right on this chart itself. So if I click Add Forecast, again, I get some default values for periods forward, periods backward, prediction interval, which allows you to control the size of those confidence bounds, seasonality, and forecast boundaries, all of which I'll talk about in a second. Just a note that prediction interval, there's some mental gymnastics associated with understanding this one, but I think simply put, basically this is saying the degree of confidence that I want to have in that predicted value. So the higher this is, meaning the lower tolerance I have for the value to fall outside of the confidence bounds, means that the confidence bounds will be wider. If I crank this down, I'm saying I have a higher tolerance for the future values falling outside of the confidence bounds, so the confidence bounds will be smaller. So you just have to walk the balance between, the level of accuracy that you would expect before turning the results around to your business users versus the size of the confidence bounds and whether or not that context will make sense to your business users. And then lastly, seasonality. So if you set this to custom, you're basically dictating the number of periods in a single season. In this case, my chart is set to month. So one period is 1 month. If it was set to hours, one period would be 1 hour, et cetera, et cetera. And then I would say the number of periods that I know constitute one season in my data. I can also apply forecasting to charts where I have multiple metrics, and you can see here that the orange future predicted points apply to each of these metrics independently. Here's an example of where I might use forecast boundaries. So, say this chart was revenue. Hopefully it isn't, and hopefully your revenue is not dipping close to 0, but let's just say for the sake of argument that it was. It doesn't really make sense to have negative revenue, whereas here, just based on the trend of the data, our algorithm is predicting revenue values below 0. So here I could set a forecast minimum of 0 and at least say that, even despite the previous trend, I know that I'm never going to go below 0. So sort of just show me when I'm going to hit that point. You could also do the same for a maximum. And of course, there's a couple of different contexts in which this will make sense. It does not only apply to looking at sales or revenue data. Okay, 2 more quickly. With our forecasting algorithm, you can also set periods backward or backcast. And basically this allows you to do two things. One is just sort of get a gut feeling of accuracy. So how well do we use past data points to at least predict one value further into the future? And so you can see here that we're pretty well mirroring the trend of the actual data, and it just helps you have more confidence in those future predictions. But as well, this way you can do some forecast versus actuals or attainment analysis. So how well did we achieve what QuickSight would have predicted we would have for revenue on each of these periods. And then last but not least, what if analysis. So on any of these future predicted points, if I say, well, for February 2017, QuickSight thinks I'm going to make 2.3 million. I know that it's going to be closer to 2.5 just because I know, February for my business tends to be a critical month. I click on that data point. I hit what if analysis. Just quickly change this to 2.5 million. And hit apply. And what that will do is show me both the original forecast as well as this dream scenario where I hit my target of 2.5 million. So slightly over, I hope that helps demystify some of our ML Insights capabilities. I hope these capabilities are useful to you. I am frequently on our community, so if you have any questions about these things, I'll likely be the one to answer you. And I hope you enjoyed the presentation. I'll hand it back over to Jill.
Thank you, Chris, and thank you, everyone. We've gone over just by a minute or two, but I wanted to thank you for your time today and let you know two things. First, we'd love to hear your feedback. If you had a moment to respond to our survey, I did put the link in the chat window and it's here on the screen. I also wanted to call out that we post on our community all the upcoming workshops like this one in our events section. So if you enjoyed what you saw and learned today, we'd love to invite you to another follow-up session. As you can see, we're doing sessions almost weekly for the next couple of months on all kinds of things, including best practices and building your first dashboard and using, groups and namespaces. So lots to learn there. Final note that we are answering questions within the community with our subject matter experts throughout the morning, and really appreciate your attending today. If you do post a question that is related to this content, you can add the hashtag QLS-anomaly, and that'll prioritize it within the community for our QuickSight subject matter experts to answer. So once again, thank you so much for your time, and we will post the content here up to our QuickSight YouTube channel by the end of the week. Thank you again.